Hello everybody. Today we will discuss about some measurement topics. Measurement in that measurement topic, there is a very vital instrument. That vital instrument is our PMMC. That PMMC, it is a abbreviation, and that it is an abbreviation. That abbreviation for what? Na for what? That it is a permanent magnet moving coil. Permanent magnet moving coil, that is the PMMC, and it is a very vital instrument. And if you go for the history, in always instrument plays a vital role in developing the society. So that's why whenever in the prehistoric age we are reading about anything, we are researching about their instrument. So instrument shows their finishedness or their research capability, everything always. So PMMC is such a component and very vital in all the aspects of measuring things. So whenever we go for the measurement, so it always comes to instrumentation engineers that PMMC can be a good alternative. So, so first of all, we'll go for what is PMMC and its diagram and its construction and its working of PMMC, how it works. And in that working, I will say about what is that principle. Then after, we'll go for the pros and cons, that means advantages and disadvantages. So now let's go for PMMC. That words I have already shared to all of you, that it stands for the permanent magnet moving coil. It is also known as a d'Arsonval principle or galvanometer. The d'Arsonval, because of the scientist's name, the d'Arsonval first of all suggested that theory. So that's why it is called a d'Arsonval. Then after we will go for the then after we will go for our diagram, because before understanding that we should know that how it is constructed. Now mark that here, permanent magnet, a magnetic field is created here due to the presence of a permanent magnet. Understand my point? So there is a core that magnet, sorry, okay, yes, yes, the magnet is here, north pole and the south pole. That magnet generally, the 3D diagram I have shown here, this is the horseshoe shaped magnet, horseshoe shaped magnet or U shaped, you can say that it is a U shaped magnet. And in the U shaped magnet, the north pole, south pole, the scale here is a calibrated scale. Why calibration? I will say that in later. Then now mark that there is a core, and that core is placed inside a coil and a former. Former means, you first of all understand, it's a frame. It's a frame where the coil and a former means there is a frame, and on that frame there is a many wounds of wires, and which is said as the coil. And that coil takes the current. That coil takes the current, so current is given to the coil. Then when coil current passes through the coil, it creates some that coil experience some force, that is the mechanical force. That mechanical force, due to the presence of a magnetic flux line, which is created by a permanent magnet. So whenever that permanent magnet creates a magnetic lines of force, there the induced force is generally, that direction is always governed by the Fleming's left hand rule. That left hand rule, what is that? Now it's also is a principle here, that left hand rule, what is that? Now I remember everybody, so FMC, and that means force, magnetic flux line and a current. Whenever the magnetic flux line, suppose north to south pole, then north pole, and then current direction if there, then upward will be the force experienced by the coil. So this is the Fleming's right hand rule, and that Fleming's right hand principle works here. So in this way, that means whenever that core current passes through the coil, coil experiences a force and that coil moves. That's why its name is PMMC. So permanent magnet and moving coil. Coil moves, that's why it is moving coil instrument. Understand my mobile? Then after what happens? When coil moves, the coil is mechanically connected with a very light pointer. That pointer also moves. When a pointer moves, that pointer is designed and placed in such a manner so that what happens? Now it moves over a calibrated scale. The position of the pointer indicates the measurement of the given input quantity. We will go for again also that. Then after that is the diagram part of it. Here mark that the north pole, south pole, core, that pivot and jewel bearing. That means to support that core, there is a arrangement, mechanical arrangement here, both side pivot and jewel bearing, pivot and jewel bearing. That there is a spring. The spring is always for the controlling point of view. Then we'll construction. What is it? Then like this construction we have already shown that mark that the construction point of view, what it requires to construct. Now it requires to construct PMMC consists of following components. That components are pointer, horseshoe shape, magnet, permanent magnet, calibrated scale, and there is a pivot and jewel bearing, balancing weights, and coil and former and core. There is, these are the following parts which makes the PMMC. Then after working of a PMMC. Now PMMC, when in the diagram I have stated to again I am stating here, and also in the diagram I have shown you that how it works. Now arrangement you try to recapture that arrangement is that when there is a coil, through the coil current passes through that, and when current passes through the coil, it experiences a mechanical force, and that is the principle of a motor. So that's why we always say PMMC works on the principle of a motor principle. It works on the motor principle. So that's why it is called the current which is to be measured. Suppose what we want to measure, that is given to the input side, and that goes to the coil, and when coil carries that current, what happens? Now it experiences a mechanical force due to the presence of a magnetic field, and that's why that coil moves. So this is the main crux point of the how the pointer indicates the current. Current goes, coil experiences a force, and coil moves, and coil is connected to the pointer. Pointer moves. When pointer moves over the calibrated scale, the position of the pointer indicates the value of the quantity of the current which is applied at the input side. And again we have left one of the topic, that why calibrated scale? Because that scale has to be calibration. Why calibration? That has to be standardized. Otherwise any scale you will take, then it will not work, and that has to be calibrated in terms of voltage if you want to measure the voltage, in terms of a current if you want to measure the current, and in the further topics we will also discuss how we can modify that scale to measure the temperature. These are the coming topics we will cover also. That is, these are the things. Then part of that write down, look at whatever I have said. The motor principle works there. The pointer moves and the calibrated scales. Then after pros and cons and advantages of PMMC, and it is a very compact instrument. That is the main advantage. It is a very compact instrument, and it has no mounting problem. Suppose you want to mount it in any position, it will work. There is no such restriction. You have to mount it vertically, horizontally. There is no such. That's why in most of the ships that PMMC instrument is being used, and it is very rugged instrument. Rugged instrument means and a rough and tough environment it can work. Then it is compact instrument and it takes less amount of power. External power consumption is very low here is that. That is the advantages of any of the PMMC instruments, and it gives very high accuracy also. Accuracy point of view, it gives very high accuracy point of view, and its loss. Any instrument have some losses. Its losses are also there, but very minimal losses are there. Then we will go for the cons. Cons means disadvantages. Disadvantage, any instrument, it is not, it cannot be said that an instrument is in an absence of disadvantage. It is obviously disadvantage will be there, but there is very minimal disadvantage there, because one disadvantage is it works only on DC. It can measure DC and works on only DC, but some modification can be done in order to measure the AC, but in the pure form of sometimes it is expensive, because some of the parts here like coil, permanent magnet, we cannot cut the cost. So if we start to cutting the cost of the in the magnet, it will create again problem. So that's why you have to be a quality, you have to put there a quality magnet. So for quality magnet it takes some cost. That is the one part of the costing is the somehow is the also a disadvantage in case. But where accuracy is very high priority, we have to pay for that cost also. Then it is very delicate instrument and it shows error. It shows error. It cannot be said an errorless instrument, still scientists are also searching up. Errorless instrument, it cannot be happen, but it has error due to some magnetism loss, because magnetism why magnetism loss? The magnetic property is a natural property of an iron. It's a natural property, and time by time, suppose in 1 year or 2 years, and by the time the permanent magnet losses its magnetism. When magnetic property or magnetism lost by the permanent magnet, and its work efficiency also losses. So that's why there is a magnetism loss, and due to magnetism loss, its efficiency also we have to face. So these are the some of the disadvantages are there. Thank you everybody.